Welcome everyone. Let's talk about concavity. Let's start with a really intuitive approach. If we have a graph like this, where the graph is looking down, we will call it concave downward. And if it's looking like this, like a boil looking upward, we will call it concave upward. We have a theorem for this, second derivative test. If second derivative is greater than 0, we will call it concave upward, or the short of it concave up. And if the second derivative is less than 0, we will call it concave downward, or the short of it concave down. For example, f of x is equal to x squared. We all know how this graph looks right? Like this. Clearly concave upward. First derivative 2x, but we need the second derivative, which is equal to 2, is greater than 0, so the graph of f is always concave upwards, as we know. Another important definition for us, inflection points. Point of inflection is the point where the curve changes its concavity. In simpler terms, it's where a curve goes from being concave up to concave down. Y is equal to x cubed. We should change the color because white is not visible here. Let's try orange. At 0, let's focus on 0 from the graph. Left side of the 0, concave is clearly down. Right side of the 0, concave is up. 0 is an inflection point for us. It is really nice that we have the graph for this function, but sometimes we will not have the graph, and what will we do? We will apply the second derivative theorem. Find the second derivative and make the sign table of it. From the table, we can find inflection points and concavity. Let's try to apply it for the x cubed we have here. I need the second derivative. First derivative is 3x squared. The second derivative is equal to 6x. How am I going to make the sign table? I will let this be equal to 0 to find the root. My root is 0. Let's make the sign table. I pick a value between 0 and infinity. 1, this part is positive. From left, negative. I will say negative parts are concave down and positive parts are concave upward. And I have an inflection point at 0. So the roots for the second derivative gives me the inflection point. It might not. It might not. We have to be careful. It might not. But since it is changing, as we can see at 0, 0 is an inflection point. So 0 to f of 0, which is equal to 0. Where's f of x? F of x is equal to x cubed. Plug the 0 in, 0, as we can see from the graph. Now let's see examples. Examine y given function for concavity and points of inflection. I need the second derivative. First derivative is 12x cubed minus 30x squared minus 24x plus 12. Second derivative is 36x squared minus 60x minus 24 is equal to 0 because I need the sign table of it. All right, really nice. Can we do some simplification? It looks like I can divide everything with 12, which gives us 3x squared minus 5x minus 2 is equal to 0. 3x, x, negative 2, negative 2, and 1. So this is equal to 3x plus 1 multiplied by x minus 2. We did not make a mistake, right? Let me see. Negative 6x. Yes, it looks correct. This is equal to 0. From here, our roots is negative 1/3, and the second root is 2. Let's make the sign table for the function. For the second derivative. I have 2 points. One is negative 1/3, and the other one is 2. Yeah, I'm struggling with space as usual. Negative 1/3 and 2. Split is infinity. Split is negative infinity. Let's see, where's the second derivative? It is here, 3x squared minus 5x minus 2. Plug a value between this interval first. Let's try 3. 3, 9, 27, 27 minus 15, so it is positive, right? 3, 9, 27 minus 15 minus, yes. Let's try 1, 3 minus negative, clearly. And bit after negative 1/3, I have, let's try negative 2, for example. 12, it's positive. So, between this, in this interval, I am concave up. On this interval, I'm concave down. And on the last interval, I am concave up again. What about the inflection points? I have 2 where the concavity changes. One is here and one is here. So the first one is negative 1/3. And I need to plug this in the function. I really don't want to. Yeah, I'm gonna leave it like this. It's okay. You can try to evaluate by yourself. Let's write inflection points. And the second inflection point is at 2, f of 2. Don't forget you need to plug in for the y. Like, you cannot plug this in for the second derivative to find the inflection points. Let's write the concave up part. It is negative infinity to negative 1/3 union from 2 to infinity. Concave down is from negative 1/3 to 2. Find equations of the tangent lines at the points of inflation of given function. Okay, really interesting question. First, let's start with finding the inflection points. First derivative is 4x cubed minus 18x squared plus 24x. Let's see, it looks correct. I'm trying to just make sure. Okay, differentiating it again. 12x squared minus 36x plus 24 is equal to 0. If I divide with 12 again, x squared minus 3x plus 2 is equal to 0. This can be written as x minus 1 multiplied by x minus 2, which is equal to 0. First x1 is 1, and the second root is 2. The question does not ask the concavity, but it's okay, since we're learning. The points are 1 and 2, right? Yep. 1, 2, infinity, negative infinity. Let's start from this interval. Let's try 3, where we can use this one as well. It is positive. Let's pick one between 1 and 2. 1 over 2, for example, it is negative. Between 1 and negative infinity, I have 0, which is positive. So therefore, these points are our inflection points. We need to find them this time because of the question. Our first inflection point is 1. 1 minus 1 minus 6 plus 12 minus 8. 6, 6, 7, negative 1. Our first inflection point. Our second, let's call this point A1. We don't need to write, let's write like this. And the point A2 is 2, 2 to the 4th power, 16, minus 8 times 6, 48, plus 4 plus 48, minus 8 is equal to 8. What I need is the slope for the tangent line. Do you remember y minus y0 is equal to m multiplied with x minus x0 is the equation of the tangent line. I need the slope. I will find it from the first derivative. Let's find ma1, slope of the first point, first tangent line we have. You need to plug the one in the first derivative. 4 minus 18 plus 24, 10. ma2, slope of the second point, which is 2. 8, 4, 32, minus 2, 4 times 18, 72, plus 48. 72 negative 40 from here, plus 48 is 8. Let's write tangent line A1, y plus 1 is equal to 10 multiplied by x minus 1. You can do the algebra, it's not that important at this point. Tangent line of A2, let's see, y minus 8 is equal to 8 multiplied by x minus 2. Again, we can say concave up, concave down, concave up as well. The question did not ask. Examine the given function for a concavity and points of inflection. What am I going to do? I need the second derivative. First derivative is 2x multiplied by x minus 2 minus x squared over x minus 2 squared, which is equal to 2x squared minus 4x minus x squared over x minus 2 squared, x squared minus 4x over x minus 2 squared. Let's differentiate it again. 2x minus 4, we can write 2 multiplied by x minus 2 instead. We will multiply this with x minus 2 squared minus derivative of the denominator. 2x minus 2 inside is 1 multiplied by x squared minus 4x. This is over x minus 2 squared. I need to do some algebra inside. Let's see. I see some common terms. So instead, let's write 2. I will factor out 2 multiplied by x minus 2. Inside, I have x minus 2 squared minus x squared. This minus will turn this into a positive sign, plus 4x. This is over x minus 2 squared. Okay, what can we do now? I could expand the x, so maybe, yeah, let's expand that. X squared minus 4x plus 4 minus x squared plus 4x over x minus 2 squared. These will cancel each out, these will cancel each out, and one of the x minus 2's will also cancel each out, but let's write it here one more time. There's nothing left inside? Oh, there's 4 left. Instead of that 4, let's write 8 here over x minus 2 squared, x minus 2. Can write it like this. Wait, this has to be the 4th power. Oops. Because we differentiate when it was square, so we will take the 4th power of it. Therefore, I will have to write 4th power here, which gives me 8 over x minus 2 cubed is equal to 0. As we can see, there's no values of x that makes this 0. So when I make the sign table for the second derivative, what I have to do is put the values that makes the function undefined, which is 2. And my original function was x squared over x minus 2. So 2 is not defined as well. No matter what, this cannot be an inflection point because at point 2 the function is not defined. Let's see the concave up and concave down parts. Let's plug in a value between 2 and infinity, for example 3. It is positive. Let's think a value between negative infinity and 2, for example 0. It is negative. So here it is concave down, here it is concave up. Concave up from 2 to infinity. Concave down from negative infinity to 2. We don't have any inflection points since 2 cannot be an inflection point because it's not defined on the graph. Find the inflection points of the function x multiplied by e to the negative x. Okay, f of x is equal to x multiplied by e to the negative x. If we differentiate this according to the multiplication, e to the x, differentiating the second term minus e to the negative x by x. Let's differentiate this one more time, differentiating the first term. The second term, okay, I'm going to keep the negative sign and differentiate this part. Negative e to the negative x by x plus, this derivative of this one multiplied by this is negative e to the, wait, plus e to the negative x, okay. Which is equal to negative e to the negative x plus e to the negative x by x minus e to the negative x. It is equal to negative 2 e to the negative x plus e to the negative x minus multiplied by x. Negative 2 over e to the x plus x over e to the x is equal to 0. Solve this if you can. What is this? X minus 2 over e to the x is equal to 0. X is equal to 2. Ah, alright. Is the function defined at 2? It looks like it is. So therefore, the point we are talking about is at 2. Second derivative infinity, negative infinity. Let's pick a value from here. 3 clearly positive, 1 negative. So concave down, concave up. And the point is x e to the x. So therefore the inflection points will be